So we're going to talk about what happens when you have a project and you don't know what coordinate system you're using. I'm going to just kind of quickly go over coordinate systems real quick. Just show you how to find your project. So when you start your project, you get the lat-long coordinate system, and if you hit blank empty map, this is just basically centered on 0, and you get degrees. That's your coordinates in degrees. And then if you add your Google map, let's go with Google Hybrid, you get, this is probably in meters. So there's some sort of spatial awareness here that is measurable. That's kind of important, but not very useful. Okay, and then we know our project is in Honolulu. So we're going to zoom our map to Honolulu and start adding data, and then start looking for coordinate system that should match our project area. We have a FLO 2D project that's really old. You can see that it's old because the oldest exec.dat is from 2003. So I think this project is from around 2003. So that means that the coordinate system is probably pretty old. When you're dealing with federal, state, county, or city agencies, they could all be using different coordinate systems based on their survey. You know, it's written into their survey methods, and then sometimes they don't update those, even though there's a more modern coordinate system. And that is definitely the case in, things that are dating back to about, the start of the 2000s. They were probably all in older coordinate systems, all projects. So you have to sort of identify what kind of coordinate system you're looking at. So if you look at a coordinate system and you're looking at something like this, y coordinate has 5 decimal places, or not, I'm sorry, not decimal places, but 5 numbers, and this one has 6, then you're probably looking at something similar to state plane. And if you're looking at maybe 6 and 6 or 7 and 6, then you're looking at like NAD 83 possibly. And then if you're looking at something like your project's in meters, then you're probably dealing with UTM, and so then you're into zones. And then of course you're dealing with maybe upwards of 6 to 7 digits, maybe more, maybe up to 9 digits for UTM. And so this is spatially variable data. It is, we know this project is in the United States, so it's in feet. I have a feeling that this was done for the Army Corps of Engineers, but could have also been done for the city of Waikiki or Waikiki Beach, whatever city that is. And we know that and we know the project name is Alawai, so we know it's the Alawai Canal, right? So we know we're in Honolulu. And we know we're on Honolulu, and we know we're in Waikiki. So let's use this information to kind of help guide us. So first off, I load an empty QGIS project, and we load this data using the text delimiter. So I'm going to grab, and if that file is more than like 1 megabyte, just load a bit of it, just load like the first several thousand lines of data. It's delimited text, and it's going to have ASCII is the FLO 2D format. So if you can't get this, if you need to export this data, you need to export it with the correct encoding. If you need to use this in GDS, okay, so want to be careful about that. Now we have a custom delimiter. It's space delimited data. Okay, so that's done. Records and fields, no line, there's no header, so there's nothing to discard. There's no field names, so there's nothing to put here. See, if I check that, that's clearly not a field name. We do want to detect the field types. That'll tell us if that's an integer or a decimal value or a string. And we do want to discard empty fields, and we do want to trim the fields. Okay, and okay, that's done. Then our geometry data, it does have geometry data because it has X, Y, Z. Or no, just X, Y, no Z, sorry. This is field 2, that's our X coordinate. This is field 3, that's our Y coordinate. And I don't know why, but this always does set it to Hawaii. So there might be some smart code in this that knows that, and that I don't know that, but you know, because I don't read enough about coordinate systems, because I always just do this the hard way. But I know this is wrong. But we know it's in Honolulu, so we can come to and learn a little bit about state plane zones in Hawaii. What state plane zone is Honolulu in? And AI gets it wrong. And that really hurt me the first time I did this because I just believed AI. But if you go down a little bit further to a .gov, you'll see that Honolulu is Zone 3. State Plane Zone 3. And if you go to like a, well, this is a .gov, so this is probably federal, but this is also probably new. So if you go to a older zone, like an older map, you can get a list of these and you might get an idea. Or if you go to the city or the state of Honolulu or the city website and you look up their spatial reference, like sometimes they'll have it listed on their survey page, what spatial reference that they're using and what vertical reference that they're using. So that's a big deal. Okay, so what do we got here? We have Zone 3, so that's important. So I'm not going to worry about this right here. I'm just going to click Add and Close. And what you're going to see is that it didn't put it in the right spot. Okay? So what we're going to do is we are going to start changing our base coordinate system and our points coordinate system until they align. And that's very easy. You just click this, you filter it by Hawaii, and I'm going to copy that into my clipboard, and then you open up Transverse Markator and you just start. So this one is the first one. And I know that's a pretty old one, so let's go ahead, and it's a good place to start. Let's go ahead with that one. Click Apply, right click this layer, and we will go to Layer CRS, and make sure that this number matches this number, but it's always that one. And you can see that indeed it did align to the correct location. But if we zoom in on it, we can tell right away that it's not aligned quite right. So that's good, because we know it's not, we know it's close to zone 27. So we know it's older than 83. Okay, so we don't want to get into those zones that we know are not any good. So we put Hawaii back in here. Now we don't want to use 83. We definitely don't want to use any of these newer ones. So if you look at these, the only ones that are not 27 are all the way down here. Let's keep going, sorry. And to this guy right here. So everything else is 83. And so we can grab this guy right here, click Apply. That's going to apply it to the map. But that did correct it, but I still think what we want to do here is we want to come here, right click, set the CRS, and then we want to set that to the one that matches down here, 3563. So like I said, it's always this one right here. And now we have that coordinate system. However, this is delimited text data, so as soon as I export this or move it or anything, it's not really going to remember that coordinate system is correct. So it's still ignorant of its coordinate system. We just defined it right here. So we can save this, and hang on a second. So we can save this project. Sorry, I am totally in the wrong spot because, all right, so let's just call this coordalign.qgz. I'll click save. All right, no problem. So that's the centroid of every grid element right there. All right, now let's take a quick look at FLO2D data. So FLO2D data is pretty handy in that everything in the DAT files is tied to the grid number, right? So the only files that have coordinate system numbers are cadpoints.dat and topo.dat. So that means that we only have to modify one of these to like we only have to transform one of these files, and we can just delete the other one. So if I transform cadpoints.dat, what I'd want to do is I would want to delete topo.dat, neighbors.dat, and manningsin.dat. And I would transform cadpoints.dat and run FLO2D in the FLO2D engine, and it would rebuild those other files. Okay, so let me pause the video and I will practice that transformation, and then I'll show you how to do it. Okay, so I think I found a method that will work pretty good for this transformation. So what we want to do is we want to save this data as a different layer. So here's what we'll do. We'll export this, save features as, and let's make it a shapefile. But let's change the coordinate system from this old coordinate system to, let's say we want to align it to the modern coordinate system, and then try to get some LiDAR data to reassess the elevation data of the grid. That's the key here, okay? So we're going to export it in this coordinate system, but you're gonna find that field 2 and 3 are not actually gonna be transformed. Only the geometry data will be transformed. So I will click, let's do this. Let's just, I already saved it, so let's overwrite that file, and we'll click OK, and it's going to add that file back to the map as a shapefile, and you can see that it's perfectly aligned. Alright, it's perfectly aligned to our project, but if you look at the attributes, they are still the old projection. So if I select and copy all this data, I can put this into like Excel or something. I don't know, let's try Excel. Let's try Notepad++. Just see what it gives us. So you can see here what we have is, this is, oops, sorry, I want to get to the top. I was wondering why those numbers look so weird. Okay, so you can see here that we have is, this is our point geometry. So this is our X coordinate and our Y coordinate. And this is the old X and Y coordinate. And this is NAD 83, the high resolution NAD 83. And this is the old Hawaii coordinate system. So if you wanted to update cadpoints.dat, you could just easily rearrange this file and save it as a text file. Save it as an ANSI text file. So let's just give that a shot. We can, I would do it in Excel maybe, but let's see. We have to split these geometries. We have to kind of refactor this data a little bit. So first of all, we don't need that. And we don't need these open and closing parentheses, because that's going to mess up our numbers. And our original data was just aligned to a 0.5, and our new data is not, so not sure what that's going to do. So let's see what happens if we wait, let's do this. Control or home, control shift home, or no, just control home and control F, and we will look for that and replace it with nothing. Yeah, that's fine. We'll replace it with nothing. Replace all. Oh, sorry. Let's get that back to normal. And we will look for that and replace that with nothing. Replace all. Okay, and we will take our spaces and replace them with a tab. And we've got to get all the way back here or we'll miss them, and replace all. And then we will save this. No, we don't have to save it. We'll select it and pop that into Excel. I'm sure there's way better ways to do this in Python and stuff, but it's a little bit more visual in Excel. So we whoops. Control A, C, Control V. Okay, there we go. So we can just get rid of that. And these two can be moved over. How do we do that? And these two can be also moved over, and hopefully if we set those to like a decimal value, like say 2 decimal places, they will be a little more regular because we want them to be exactly, I think that cell size is 97, 100 by 100. So we don't want them to be off by these tiny little variables. So we want that to be rounded to 100, but that's going to mess up our alignment. Let's see. Let's just try to round it to 0.8. Let's try like that. Let's see. .9. Yep, that looks like that works. All right. So let's do that. Wait, let's do this. So we go Shift and then End. No, Control Shift down. Okay, I said Control Shift down arrow, copy back here, paste, and then Control Home. And then our space, then this, wait, how many spaces is that? That's so perfectly aligned. That's fine. There's not much we can do about that. So we'll take our tabs, copy that tab, and just put some spaces in there. And the next time you run it, FLO2D will fix that alignment. Replace all. Okay, and let's just save that as key ID PTS. Let's call this 83. No, HARN 83. And let's see, dot, dat. Okay. Now, let's get out of here and out of here. Let's turn these guys off and let's import that data back in here and see what happens to it. Okay, so that's this guy. And everything should be the same. So all we have to do is go 2, 3, and this goes to, this should be, no, that's the one with this one. And we click Add and Close, and it has the perfect alignment. Wait a second. Let's now change this to, okay. And now you see it still has a perfect alignment. So now if you wanted to sample the LiDAR, the Hawaiian LiDAR data from the USGS site, you could update your elevation data and, you know, update your streets and things like that. And that would be a way to rebuild your project and reproject your project.